All right, everybody, welcome back. Ready for another deep dive.
Always ready to dive in.
Today, we're going deep on something that might sound kind of dry, but trust me, it's important stuff. We're talking file system permissions.
Ah, yes, the gatekeepers of the digital world.
It might seem like something only tech wizards need to worry about, but honestly, everyone who uses a computer should at least have a basic understanding of this.
Absolutely. In this digital age, knowing how to control access to your data is more important than ever.
So basically, we're going to be looking at who can access your files, who can change them, who can even run them if they're programs.
And we'll be talking about how to use some Linux commands to manage all of that.
Exactly. And why Linux commands?
Well, Linux is known for its robust security features and its granular control over file permissions. Understanding these commands in a Linux environment can really give you a solid grasp on the fundamental concepts.
Makes sense. So let's jump right in. First up, we have the chmod command. Now, this one's all about changing file permissions. Like, let's say you have a text file with, like, top secret notes for your next big project.
Ooh, top secret notes. Sounds intriguing.
Right. And you want to share it with your team, but you only want them to be able to read it, not actually make changes.
Okay, I see where you're going with this.
So how would we use chmod to do that?
All right, so chmod works by assigning read, write, and execute permissions for the owner of the file, their group, and then everyone else. In this case, you'd want to give yourself, the owner, full permissions, which is read, write, and execute. But for your team, you only want them to be able to read the file.
Gotcha. So we're talking like read-only mode for them.
Precisely. So you'd use the command chmod 744notes.txt.
744. Now, those numbers look a bit like a secret code.
Haha. Yeah, it might seem that way at first, but it's actually pretty straightforward. Each digit represents a set of permissions. The first digit for the owner, the second for the group, and the third for everyone else.
All right, so break it down for me.
Okay, so think of it like this. 4 stands for read permission, 2 is for write permission, and 1 represents execute permission. You just add those numbers up to get the permission level you want.
So 7, the first digit in our example, would mean?
Exactly. 7 means read 4 plus write 2 plus execute 1, all permissions for the owner.
Ah, so the 4s in 744 mean the group, and everyone else can only read the file.
You got it.
Okay, that makes sense. But what if I want to give my team permission to edit the notes too?
In that case, you'd want to give them write permissions as well. So the command would be chmod 764notes.txt.
So 6 means read and write access.
Exactly. You're getting the hang of this.
I'm trying. So that's chmod. Pretty powerful stuff, huh?
It really is. It gives you a lot of control over who can do what with your files.
All right, next up we have chown. What does this one do?
Chown is all about ownership. So let's say you've been working on a project and now you need to hand it off to someone else.
Wait, like passing the torch.
Exactly. You can use chown to change the owner of the files to the new person.
So if I finished building an awesome new app and wanted to officially give it to my development team, I'd use chown.
You got it. You would use a command like chown devteam.developers myapp.esh.
Devteam.developers? What's with the colon?
Good question. That colon separates the new owner, which is dev team in this case, and the new group, which is developers.
I see. So it's transferring the ownership to a specific user within a specific group.
Exactly. So now the dev team user and the developers group have full control over that app.
Okay, that makes sense. But what if I just want to change the group associated with a file, not necessarily the owner?
In that scenario, you would use chgrp.
chgrp. All right, so this is like adding someone new to the project team.
Exactly. You're essentially saying, hey, this person is now part of the group that can work on this file.
So how would that command look?
Let's say you want to add a new developer named newdev to the developers group for that app you were talking about.
Yeah.
You would use the command chgrp developers myapp.esh.
Straightforward enough. So chown for changing the owner and chgrp for managing group access.
You got it.
Now, I've also heard of something called mask. Something about setting default permissions for new files.
That's right. Mask is all about setting the initial permissions for any new files or directories you create.
Okay, so it's like laying down the law of the land for any new files that come into existence.
Exactly. It's like setting a baseline level of security.
So if I'm working on something super sensitive, I want to make sure that no one else can access any new files I create, I'd use a mask.
You got it. You could use a command like umask077. This would give you full permissions, but block everyone else from even reading the files.
Wow, so 077 means no access for anyone but me.
You got it. It's the most restrictive setting.
Okay, that makes sense. So mask is like setting up a security perimeter right from the start.
Precisely. It's a proactive approach to security.
Okay, now we're getting into some pretty advanced stuff. We have 2 more commands. set facle and get faculty.
Now we're talking about access control lists, or ACLs for short.
Access control lists, that sounds pretty intense.
It might sound complex, but it's all about having more granular control over file permissions.
More granular, what does that mean exactly?
Well, with chmod, you're limited to setting permissions for owner, group, and everyone else. But with ACLs, you can get super specific. You can grant or deny permissions to individual users or groups.
So it's like having a VIP list for your files.
Exactly. You can say, hey, this specific user can read this file, but not this other one, or this group can only execute this program, but not modify it.
Wow, so when would you actually need that level of detail?
Imagine a scenario where you have a server with a ton of sensitive data, and you have different teams that need access to different parts of that data.
Okay, I'm seeing how that could get complicated.
Right. With ACLs, you can really fine-tune who has access to what. So you could give your accounting team read-only access to financial data, while your developers have full access to the source code, but no access to the financial data.
So it's like a super customized security system for your files.
You got it. It gives you ultimate flexibility.
All right, so how do we use these set facle and get facle commands?
Set facle is used to set the ACL entries for a file or directory, and get facle, unsurprisingly, lets you view those entries.
Okay, so set facle to create the rules and get facle to see what those rules are.
Precisely.
I think we've covered a lot of ground today. We talked about tradesman, chown, THGRP, mask, set facle, and get facle.
A whole toolbox of commands for managing your file permissions.
It's pretty amazing how much control you have over your files and who can access them.
It's really all about taking ownership of your data and making sure that it's protected.
Absolutely. So to everyone listening out there, we encourage you to take a look at the permission settings on your own devices. Think about who has access to your files and what level of access they really need. It's a simple step that can make a huge difference in protecting your privacy and security.
And remember, in this digital world, knowledge is power. The more you understand about how things work, the better equipped you are to keep your data safe.
Great advice. And that's it for this deep dive. Until next time, stay curious.
And stay secure.